and just just write it. Thank you a lot. Two years is and top is these steps is from a few symmetric elements in simple matter.
So I say with our micro. Good morning, everyone. My name is Thao Nhi, and I'm extremely honored to represent our paper, algebras of skew symmetric elements in simple Levin path algebra, and revisiting her stance question. This paper is written by me and joint work with Dr. Wenbikan, the man who is the host of this workshop today. Although I can't do it, but shall we give him a big applause to because without him, we can't organize this such international workshop, right? So a quick abstract to briefly introduce our paper. This paper will investigate the set of skew symmetric elements of LKE, and we also give a negative answer to her stance question. So what is her stance question? He said that if A is a simple ring with an involution of the first kind, is it true that Ka is the square bracket of Ka comma Ka? Historically, this theory has been proven to be incorrect because there are several counterexamples of this question. But specifically, in 1982, P.H. Lee provided an example of a division ring D with an involution such that K is not the square bracket of itself. Additionally, in 2014, Jenny Hennig constructed a simple locally finite dimensional algebra with the same property. And in this paper, we also give a negative answer to this question by the context of LBA. And of course, there are certain reasonable reasons why we do so. First, because we already knew the simplicity theorem, right? This gives us the necessary and sufficient conditions of E to make LKE be the simple ring. And we of course can describe the involution, how involution map acts on the elements of LKE. And one can verify that that involution is of the first kind. So the most difficult part is to describe the elements of Ka, where A is LKE. And we also give a class of counterexamples for this question. So now I'm about to elaborate into background of this paper as well as some relevant concepts. In the definition of the Lie algebra associated with A, every associated algebra A over a field K gives rise to a Lie algebra by considering the vector space structure and defining the Lie brackets as the square brackets of A and B is AB minus BA for all A and B in bit A. And that the Lie algebra obtained in this way is called the Lie algebra associated with A and often denoted by A minus. And when A equipped an involution map star, so what is the definition of a map star? A map star from A to A satisfying three conditions. First, A plus B star equal A star plus B star, and A B star is B star A star, and the last one is A star twice become A. And what is the definition of the evolution of the first kind and the second kind. If A star is A for an A in Z and where ZA is the center of A, the evolution of star is said to be the first kind. And in contrast, it's called the second kind. And let me remind you the set of skew symmetric elements of A. It is the set of elements in A such that x star equal minus x. And it's clear that evolution of the if star is an evolution of the first kind, then Ka is a Lie subalgebra of A minus. So next, how evolution of star can act on the elements of LKE. The mapping start from LKE to LKE, which extend V to V, E to E asterisk, and E asterisk to E, for all V in E0 and E in E1. And fixing all elements in K induces an evolution of LKE. And this is called the standard evolution in LKE. We can verify that this evolution map star is of the first kind. So now let's go into some main results. Do you remember the first primary algebras? The first one is we try to describe the element of KL. KL here means KLKE, but we usually denote the letter L instead of LKE for short. And it really depends on the characteristic of the QK. So the first case that the characteristic of a field K is not 2, and we can describe KL like this. This one K of gamma lambda asterisk minus lambda gamma asterisk, such that gamma and lambda satisfy those relations. And in contrast, when the characteristic of the field K is 2, we can describe KL like this. That's one K of PB asterisk gamma lambda asterisk plus lambda gamma asterisk, where P, gamma, and lambda satisfying those relations. And we move on to the second M of this paper. We also get some of the condition for a graph E to be a negative answer for a husband question. Yeah, we can prove that in case E contains a cycle, this make KL is different from the square brackets of KL and KL. Let me consider this example, the graph Rn. Rn be the rose with n petals. And we can figure out that LK or N is a simple ring according to the simplicity theorem. And we also can prove the inequality, right? Because we can give an element which in KL, K or N, but it's not in the bracket, the square brackets of them. So we also figure out the proposition when L be a simple level back algebra of a graph containing a cycle, then KL is different from the square brackets of itself. Yep. Okay, next slide. Do you know? We already know. Okay. And when we try to give a class of counterexamples, we try to describe the intersection of KL and the square bracket of L and L. In the case that characteristic of K is not 2, we immediately get that KL intersect with the square brackets of L and L is KL. However, when the characteristic of K is 2, the element in the intersection must be written in this form, like this. Yeah, where the sum of AI and epsilon or PI in this one. We actually we adapt this one thanks to next year. We collect. And then there is the final proposition we get. There exists a simple locally finite level path algebra L such that KL is not the square brackets of KL and KL. By using the graph like this, and in the case that the characteristic of a few K is 2, we already knew the graph AN, right? And now we will index the vertices of this graph by Z, like this, V0, V1, and V minus 1. So we can prove that it's definitely that this inequality does happen, okay? Yeah, that is the end of my presentation. If you have any question, do not hesitate to ask me. Although I can't write, but my professor can help me. Yeah, thank you.
Okay, if we don't have any question. Everyone, that's the end of our workshop. And one morning, a big thank to our speaker, Professor Ross, Professor Nam, Professor Nadine, Richard, and me. And we send a special thank to Dr. Wing Jing and the head of Department of